Problem number 11 says, using the approximation that pi is approximately 3 1400ths, find the area of each of the circles pictured below. Formula for area of a circle is pi multiplied by radius squared. We're asked to approximate, so area is approximately 3.14 multiplied by, we need to recognize that what's been given to us on this orange slice is not the radius, but rather the diameter. If the diameter is 8, the radius is half of that. Radius is the distance from the center to the edge. That would be 4 centimeters. We square that and we get 3 1400ths multiplied by 16. 4 6s is 24, carry the 2, 1 6 is 6, and 2 is 8, 3 6s is 18. Multiplying by 10, so I start with a 0, 4 1s is 4, 1 1 is 1, and 3 1s is 3. We add these up, we get 5024, and I was multiplying hundredths by wholes, so my product should be hundredths, 2 decimal places. So the area is approximately 50 and 24 hundredths centimeters squared. Since the circle is a planar figure, it's a piece of a plane. A plane is two-dimensional. That's why it's centimeters squared. It's taking up 50 and a little bit more 1 by 1 centimeter squares worth of space. For this plate, this sort of ancient looking plate, we have same formula, pi r squared. So area is approximately 3 1400ths multiplied by, this time we are given the radius, so 7 squared. So 3 1400ths multiplied by 49. Four nines is 36, carry the 3, 1 9 is 9, and 3 is 12, carry the 1, 3 9s is 27, and 1 is 28. I'm multiplying by 10, so I start with a 0, 4 4s is 16, carry the 1, 1 4 is 4, and 1 is 5, 3 4s is 12. I was multiplying hundredths by wholes, so my product should be hundredths. So the area is approximately 153 and 86 hundredths centimeters squared. Okay, those were pretty straightforward, but just asking you to apply the area formula. Problem number 12, a crop circle is pictured. Estimate the circumference using pi is approximately 3.14. And then it asks what is the exact area of the crop circle. So when we do exact area, we're not going to use any kind of an approximation, but for circumference it asks us to use this. So the diameter is shown here, the distance across the circle and through the center. I didn't show it on the circle itself because I didn't want to obscure the picture, but this is the diameter, and the formula for circumference is pi multiplied by the diameter. So our approximate circumference when we use 3.14 will be 3.14 multiplied by 100, which is pretty easy because 100 is a power of 10, so it's 10 squared, so I can just move the decimal in 3.14 2 places to the right. So the circumference is approximately 314 yards. Because circumference is the distance around the outside of the circle, it's a piece of a line. If you imagine taking a line, maybe like a straight metal wire or something, and wrapping it around the circle. If you unwrapped it and stretched it out, it would be a piece of a line. A line is one-dimensional. That's why the units for circumference are just yards and not yards squared. It's yards to the first power. It's a piece of a one-dimensional line. For the exact area, we'll use the area formula for a circle, pi r squared. And we won't substitute for pi because we can't. Any number that we would substitute would necessarily be an approximation and would no longer be exact. So we're just going to multiply pi multiplied by the radius squared, 50 squared. 50 squared is 2500. and then that's best written with the number before the pi. So 2500 pi. In this case, our units will be yards squared, because now we're talking about the area of the circle, and the circle is two-dimensional. It's a piece of the plane. Okay, problem 13. Find the perimeter and area of the trapezoid pictured. The formula for area of a trapezoid is 1/2 multiplied by the sum of the bases, base 1 plus base 2, multiplied by the height of the trapezoid. Now, we've used this formula so many times that you likely have it memorized. If you feel confident that you have it memorized when you take the test, then you I explained this in class, I'm sure, but you could add 1 bonus point to your test for having the formulas memorized. If you need a formula card, you're welcome to take one. You won't lose any points for doing that. You just won't get that 1 bonus point. Okay, the only tricky thing here is recognizing that, typically a trapezoid is shown to us like this, where the bases are the top and bottom. The bases are the parallel sides, but this trapezoid is oriented where the bases, the parallel sides, are on the left and right. So as long as you recognize that and you realize that these are your bases, the rest of it should be straightforward. So area is 1/2 multiplied by the two bases, which are 9 and 5/10 and 5 and 5/10, multiplied by the height. The height is the perpendicular distance between the bases. So this is our height, 6. So simplifying this expression, I have 1/2 of 15 multiplied by 6. I'm going to associate to my advantage and multiply the half times the 6 first and get 3. And 3 multiplied by 15 is 45. For area, it's the amount of space being taken up by the trapezoid. The trapezoid's a planar figure. It's drawn in a plane, and so it's taking up centimeters squared. It's two-dimensional, so that's why it's centimeters squared. The perimeter is the distance around the outside, so that's why we need these dimensions. We no longer need this one because that's not part of the shape. That's just showing you the altitude or the height of the trapezoid. So we just need to add up these 4 sides. We already know that the 9.5 and the 5.5 add up to 15, plus 8 plus 7, that's another 15. So we have a perimeter of 30 centimeters. Okay, that completes page 4. We'll conclude the review with the video for page 5 on the next video. Thanks for watching.